Hi everybody, this is Stephen Pugh doing another video for the City and Guilds Carpentry and Joinery course. This time we're talking about the subject of fixing timber frames and linings. Now, it's very important that we understand that the difference between door linings and door frames. A door frame is a much more substantial piece of material. It's actually a joinery frame that's been made by the joiners with a head and with the sills and all the rest of it. Linings are for the inside of a building, and they consist of just a single board. There's two sorts of linings, by the way. There's the lining that has a rebate that's built into the lining, so the door just comes into the rebate. And then there's also those linings that are a flat piece of timber, and then a small vertical stop is put in the lining against the door after the door has been fitted. So there's three different things here, but we're talking about door linings first of all. And the first thing we need to know is that a plain lining, okay, is what goes into an opening on the inside of a building. You have the jamb and you have the head, and they can be fitted together in a number of ways. It's quite traditional for there to be a housing and a small tongue to fit up inside it. And some of these heads are interchangeable. So you can have a head there, turn it over and find that it's there for the different widths of openings that are necessary. And these are normally just fitted. You can just nail them in with some lost heads, or you can actually screw them together. It's fine. What we normally do is set them out on a bench or set them out on the floor and assemble the whole thing together. But we'll talk about that in a moment. So there's different types of linings, and you've got the plain lining, which is just a flat piece of timber. You've got the rebated lining that has a rebate actually built into it, so that actually it's fixed. And then of course you have plain linings, which are much thicker, okay, for much more substantial openings. And then we have we need to understand there's different door sizes. Now I've counted here that there are at least 10 different sizes of doors, okay, 10 different standard door sizes. Of course, there may be many more, because who's to say, you know, who will make a door opening that's bigger than what we would expect. But to give you an idea, the three most common door sizes, and I'll do them in metric first, then I'll do them in imperial, are 1981 to 838, okay? So 1981 high and 838 wide, or 1981 high. They're all 1981 high, all three, but that you've got 838, 762, and 686. So these are your three sizes. Now I'll go into imperial, and you'll remember them probably easier. All the three are 6'6", 6'6", 6'6", but then you've got 2'9", 2'6", and 2'3". And may I say that amongst those, it's the central one that is the most common. So it's a 6'6" by a 2'6", or in metric, it would be 1981 by 762. And these are two numbers to get into your head: 1981, 762. Okay. Now there's different thicknesses as well. There's either 44 or 35. 44 or 35. These are just two numbers to know about. And once you know about them, if you measure an internal door at your home, you'll find it'll be 35 almost invariably, or it'll be a 44. Now, the 44s tend to be for fire doors. So an FD30 would be 44 millimeters thick. A 1 hour fire door, the FD 60 would be 54 millimeters thick. So that's well over, just 2.5 inches thick. But then they are expected to keep a fire at bay for at least an hour. Wow. And then we have two other types of standard door. We can have two standard doors for a large double door. Okay, now there's two sorts of doors like that. There's the doors that come together where the two edges are just flat against each other and they just open like this. Or you can have rebated doors whereby the one comes against the other and it just rebates inside, so that when you're looking through the gap, there isn't anything to see because it actually closes the gap like that. Now, preparing to fix these linings and frames is very important, but the most important thing you need to do before you start fixing them is have a look at the master internal door schedule. Now, the master internal door schedule is normally a fairly large piece of paper, and it will be a matrix. It will say across the top, reference number, door size, width, height, type, and it'll tell you whether it's got a self-closer. It'll tell you what the floor level is, okay, whether it's on the ground floor or the first floor or the second floor. But now as you look down the left-hand side, it'll say door 1, door 2, door 3, door 4, door 5, door 6. And as you look across, it'll tell you what that individual door is supposed to be, what size it's supposed to be, what width it is, what height it's supposed to be, the type of lintel that will be above it. It'll tell you whether it's a fire door and what type of fire door. It'll tell you whether it's a self-closing door that closes when a fire occurs. It'll tell you, of course, and a typical schedule will tell you more than that. It'll tell you what locks are on it, whether there's any finger plates, whether there's any D handles. It'll tell you whether there's glass in it. It'll tell you whether there's any kicker bars on it. It'll tell you whether there's a door closer on it. So all these things are there, and they'll be on what's called the master internal door schedule. It's important as a carpenter to become familiar with these things. I once worked in a hospital many years ago, just for the few weeks, and we were all given a door schedule, and every door was marked, door number 1, door number 2, door number 3, and you had to look down that schedule and find out exactly what was expected. You had to know which way the door opened. You had to know what handles should be on it. You need to know if there was a vision panel in it, whether there was a kicker bar on it, whether there was a self-closer on it. There was a lot of information. We were expected to use our intelligence and to figure out what was supposed to go on every door. There we are. Quite a responsibility, isn't it, being a carpenter? The other thing that we need to think about is how we actually assemble. What we normally do is we assemble the whole frame, put some timbers down on the floor, or maybe do it on a bench, even better. I normally have a bench which is big enough to be able to take a complete width of a door lining, so I can actually put the timber. I'm not working on the floor in the dirt. I'm working on a bench at a reasonable height, and I can assemble the whole frame. And there's lots of different ways of doing this, but the most important thing we need to do is we assemble the frame, put the head together, and then we put a spacer bar across the bottom, or the stretcher, some people call it. Just a piece of timber coming across at about, say, 4 inches up from the floor, and that gives us the correct spacing. That stretcher, by the way, I will take that stretcher to the top and mark it where the head is, and then bring it down to the bottom and put it in the same position. But of course, this doesn't guarantee that it's not perfectly straight. So I would be measuring diagonals to make sure that we get it perfectly square, and then I'll put a diagonal brace across. Now, a diagonal brace, people talk about little diagonals on. Well, I just put one diagonal brace across. And what that brace does is that it stops the whole frame from racking. It cannot rack. A small brace, it'll still rack a tiny bit, but with a big brace, it'll be completely solid. Sometimes I will extend those braces or those stretchers a little further, so that as I'm putting the thing into place, I can, as the stretchers are coming further and going across the surface of the wall, they can actually touch the front of the plasterboard. And this means that as you put the frame in and push it into place, it will locate itself on the surface of the plasterboard, which means you haven't got to then adjust it for plasterboard. Of course, at this particular time, there will be a number of other things entered into. It will already be screwed, double screwed all the way. So 2 screws just above the top hinge, 2 screws between the top and the middle, 2 screws between the middle and the bottom, and then 2 screws at the bottom. So that's a lot of screw holes. And what these screw holes do, they enable you, as you're putting the screws in, to be able to adjust the timber in and out, and also backwards and forwards, to get it in exactly the right position. And that is an exceptionally important point. I very often, when I'm working on jobs like this, will have what I call a pinch bar. So if I'm working on 2'6" doors, which is very common, I'll have a piece of timber which I've tidied it up and I've written on it pinch bar, and I'll use that all the time. I'll keep putting it into the frame to check that it's all exactly the right width. That little pinch bar is important. Now, there's lots of different materials that door linings are made of. Sometimes they're made of whitewood, sometimes they're made of redwood. And the difference between whitewood and redwood is that whitewood is white and the redwood is red. That's it. They're both pine, but they're different. And then, of course, sometimes they'll come as MDF. MDF is good material, but it does have its own little challenges. There can be defects in the timber that's supplied. They may be cupping, for example. Instead of it being a nice flat, you end up with a piece that's cupped like this, and that's a challenge in its own right. There's also waney edge. The waney edge is where a little bit of the bark has still remained on the timber in a particular place. So it's a door lining just the same, but it's got a tiny bit of bark on it still. What we'd normally do is take that piece away, use it for another purpose, and then put another one in its place. That's a whole piece of timber. Sometimes with door linings, they have nasty knots. If it's a live knot in particular, they tend to weep in time. So as we're putting it in place, we would cover those knots with a tiny little bit of French polish, knotting they call it, and that stops the resin from weeping through into the paintwork, because if it comes into the paintwork, it has the ability to dissolve the paintwork, and that shows the knots will show up through paint. So we just try to eliminate that. Sometimes door linings are bought in sets, delivered in sets, so you'll have 2 legs and a head, or 2 jambs and a head wrapped in plastic. Okay. So that's a really useful thing, because what it does, it enables the timber to remain clean, and it enables it to remain at a fairly high level of quality. Now, occasionally we fix door linings in the old-fashioned way, and I love doing it in the old-fashioned way. I find some of the old-fashioned ways are really good. There's 2 ways of doing this. One is that as the builder was building, so he would put some small pads into the timber, the brick opening. So there'd be sort of 10mm plywood, for example, and he'd just put them in as he's working. And the effect is that when you come to put your lining, you've got some pads to actually screw or fix into, which is always extremely useful. The other way of doing it is that you cut out your own. You cut out your own groove, you cut out your own slots, and you use a plug-in chisel to do it. Now, you use a plug-in chisel in exactly the same way as you use a mortise chisel. You need to have a look at my video about using a mortise chisel, and you'll see that you'll use a plug-in chisel in the same way. And funnily enough, I developed my method of cutting a mortise by learning how to use a plug-in chisel first. And it was copying a plug-in chisel that enabled me to develop my concept of how to cut a mortise well as well. So a plug-in chisel is a little bit like a mortise chisel, and it starts in the center and it goes down side to side and then opens out later. And what you can then is put in what's called a propeller wedge. Some people call it a plug-shaped axe, shaped by an axe. That doesn't say anything. A propeller wedge is a wedge whereby the one side is cut out and then the other opposite side is cut out, so that as it goes into the gap in the brickwork, so it turns. And as it turns, it tightens. Okay. And what you do is you put these plugs in at all of the 5 or 6 or 7 points you want to put them in. And then you take a spirit level and you mark down all those plugs, and then you cut all those plugs off exactly at that point, and then you put your lining or your frame against it and fix it. And ideally what you've got then on the other side is exactly the same width, and you cut them all down as well, and the lining should just fit in between these set of plugs nice and comfortably, and then you screw or nail into them. Just need to make sure when you're doing that you've got the head level. Very often people put frames in and then they discover when they finished and walked away that the frame head is not quite in line. So that's something that's important to know about. And also another thing that's very important is to make sure what the finished floor level is going to be. You want your frame to be at the correct height. Sometimes when you're putting frames in, the finished floor level may not be finished. There may not be any screed on the floor, or there may be something else to go down. What you don't want to have to do is to keep cutting doors every time. So you find out what the finished floor level is going to be, and you mark it with a datum and then you put your frame in to match. So so when all that's done, is there anything else that you need to check? Yes, there's lots of little checks that you need to do along the way. One of the most obvious things that you need to check along the way is that the frame isn't actually in twist. Okay, it's not in twist. And there's the most obvious way to do that is just to move your head in such a position that the outside of the one frame lines up with the inside of the other one. And as you move shut your one eye and look at it, you'll be able to see whether they perfectly are in line. If they're not, release the bottom screws or nails and just give it a slight tap and then put them back in again and get it perfectly in line. If you don't get if you don't get the lining straight, then you'll find that the door will then be in twist. Okay, it's very important to stop that from happening. Okay, so as for fixing to stud work, if you're fixing to stud work, if you're doing frames onto some timber, then that's going to be so easy. What we tend to use, so you've got 2 screws at every point up the thing. These 2 screws mean that you can push them in and out and make that frame come that way or that way. You can adjust it so that it's straight, it's not twisted. But the other thing is that just above the 2 screws, you put 2 wedges each side, and those wedges sit on top of those screws, and you can tap them in a tiny bit and tap them out a tiny bit, and that will adjust that frame in and out by half a millimeter or a millimeter. You can get it absolutely perfect. And of course, if you're using a pinch bar, the pinch bar isn't exactly the size of a door. It's the size of a door plus 2 10-pence pieces, because a 10-pence piece for an internal door is the ideal width that you're going to need to go all around the door. So if you push your door against, this is coming to door hanging, but if you push your door against the hanging side, it should be perfectly straight without any gaps. No gaps where you can see through light coming through the gap. So it's perfectly straight. You then get a double 10-pence piece, and it should go around perfectly around the top and around the bottom and up the side. That means, I don't mean 2 10-pence pieces at the top and bottom. You'd have 1 at the top, 1 at the bottom, but you have 2 at the side. This means that when you put your hinge on, it's going to move it over a bit, and as it moves it over a bit, it'll be the width of 10-pence there and 10-pence there. So 10-pence piece gap is something like around 2 millimeters. It's absolutely ideal for the width of a door. If you were doing external frames, you'd want it to be a £1 piece. So you say, why a £1 piece? Because a £1 piece is about 3 millimeters. On an external door, especially if it's timber, if it was timber, you would have to have a 3 millimeter gap. Timber does grow and shrink according to weather. Normally, you're going to be putting a door in that's dry, so it's going to be taking moisture in, and as it takes moisture in, it will increase by about 1 millimeter, and that will still enable the door to be opening and shutting. What the one fault on a door is, you never want a door to be sticking when it opens and shuts. That's a bad thing. So that 10 millimeter gap, as long as it's no more than 10 millimeter, it will be perfect, and the door will work absolutely fine. When you're fixing into masonry, you want to be using the combination. The perfect combination for fixing into masonry is a 4-inch screw, 4 inches, and a brown plug, and a number 7 SDS drill. So what you can do then, you can put in place, you can send your SDS drill straight through down to the length of the SDS bit, which is 4 inches or 100 mil. Why that deep, Stephen? Because what it's going to do, it's going to put a screw right into the very heart of the brickwork. And it's going to be a brown plug, a normal brown plug, and it's going to be a normal screw that will go straight through. This is highly adjustable. That screw can be undone a little bit, and the frame can be brought out or pushed in to suit. But the main thing is this, that 3 combination: an SDS number 7, a brown plug, and a large 4-inch screw. And that's all the screws you're going to need. In fact, funnily enough, that's all the screws you're going to need for nearly everything. Nearly everything. You can fix skirting that way. You can fit door linings, door frames. All of them can all be fitted with the same combination. So there we are. Now, people do use different types of nylon frame fixings and all that. And of course, if you're going to do that, that's fine. If you want to get used to using self-tapping screws into brickwork and so on, well, if you're going to get used to plastic packers, okay, then that's absolutely fine. I personally would always take a big box of wedges, and every single wedge is exactly the same size. So I've machined them all up, and there may be 500 or 600 in there, and I'll keep using them and using them. And as I get nearer to the end of the box, then I'll make another complete 500 or 600. So I've always got these wedges in hand, and all of my work then is consistent. Okay, right, we'll look forward to seeing you on the next video. On the next video, we're going to be talking about the fixing of rebated linings into a block work opening. Okay, see you later on then. Bye for now.